Okay, here's the third example for rotational motion problems. This ride is like the Gravitron ride. It's called the rotor. All right, the rotor ride. Pretty common ride. Spins real fast. The passengers get stuck to the wall. The floor then drops out from underneath them and they stay stuck to the wall. Very much like the Gravitron ride. But here, they're talking about forces. We haven't talked about forces in a while. The amusement park ride consists of a large spinning cylinder with a radius r, with rough walls at a given angular velocity omega. The horizontal floor of the cylinder drops, but the rider of mass m remains safely pinned against the walls of the cylinder. Minimum coefficient of friction, static friction mu necessary for the. What the heck is going on here? Force questions, and basically all the questions you start by drawing a picture with forces. It's a free body diagram. So gravity is pulling this person down. Friction is going to keep them from falling, and the normal force will push them towards the center. That's the free body diagram. In order for this guy not to fall, the force of friction has to be equal to the force of gravity. The force of friction is mu times the normal force. And the force of gravity is going to be mg. But this guy's going in a circle. So the centripetal force towards the center is the normal force, which means the normal force is the mass times v squared over r, right? That's the centripetal acceleration. So now we get this equation by plugging this whole piece for the normal force into here. We get a new equation. We get mu mv squared over r equals mg. Well, that's kind of right thing fuzz right away. The m's cancel out. So we just get mu v squared over r equals g. We want the equation for mu. So we have to get v squared over r out of there. So just losing space, I'm going to bring this over here. Mu v squared over r equals g. Let's solve this for mu. That's what we want. What is the minimum coefficient of friction? There's our unknown. So mu equals gr. So mu v squared, mu equals gr. Mu equals gr divided by v squared. Here's the problem. We're not given translational velocity, right? This is translational velocity. We need to convert. V to omega. You have that tool. Omega equals v divided by r right here. That's important. Don't forget that. Omega equals v divided by r, or v equals omega multiplied by r. So we can take this and plug it into there. And we get mu equals gr divided by omega times r squared, which would be gr over omega squared r over r squared. Get rid of the eraser. can get rid of the eraser. Yeah, finally, good. I don't know what's going on. Omega squared r squared. Now we can translate all of that. One of the r's cancel out. Right, we can get this r to cancel out one of those r's, and we will end up with the final answer after all of this work. Mu is equal to g over omega squared r. That is your final answer.